quickly. What are we going to be doing? Conditional execution one more time. What are some of the goals and objectives for today? We want to be able to work with Boolean expressions. So we talked about different data types. Today we'll talk about the bool data type or bool class. And we'll also look at logical operators. We looked at operators last time as well. We talked about arithmetic operators, plus, minus, multiplication, and so on. We also talked about assignment operators, assigning values to variables. Today we'll talk about logical operators, okay? Get some logic in there because we definitely need that in order for us to execute programs conditionally. So that will lead us into conditional executions. And it's always a good idea to be able to catch some errors. What you submitted so far, there might be, we're assuming that everybody is going to be working with stuff like a normal human being, not crazy people like myself that just want to break stuff. So we want to be able to catch exceptions gracefully and not to break our program or cause some errors that users might not find appealing. So at the end of the day, we'll learn how to use that conditional logic to create decision-driven programs. What if we wanted to differentiate singular and plural and so on and so forth? And then we'll also use exceptions output for debugging and also affecting the logic when exceptions happen. Exceptions are more or less like errors, right? So let's get started. Boolean expressions, what are they? They're pretty much any expression that evaluates to either a true or a false, okay? So are you a boy, true or false, okay? Is 5 equal to 5? As you can see in this case, it's very true. Is 5 equal to 6? No, so it's very false. Remember that true is capital T and false is capital F, okay? The case is very important. And we talked about numbers and letters, right? Strings and integers, for instance, or floats. So we're able to tell what data type when we used the type function. So if you use type and you put in the value of true in there, it will tell you that it's a bool data type or it's a bool class. So that's a way that you can always identify. If the true is in quotes, then it's a string. So true in quotes is a string. True without any quotes is not a string, it is a bool. The same for false. Does that sound good to everyone?
Yeah.
Awesome. So the next thing then we want to talk about is the equality operator. This is definitely different from the assignment operator. In Python and most other programming languages, you use two equal signs to mean equality. In this case, 5 is equal to 5. If you use just one equal sign, it will mean 5 on the right-hand side is assigned to 5 on the left-hand side, and that will give you an error. So when you're writing an expression, you want to make sure you use a double equality sign. That's a very common error that you get. So we want to avoid those common errors. And some other operators, in this case, comparison operators. I talked about logical operators. We'll talk in the next slide. But there's also comparison operators to compare the left-hand side and the right-hand side. Again, they are not assignment operators. We can use two equality signs to say the left hand is equal to the right hand. Or we can use an exclamation mark and an equality sign to say it is not equal to. There are a bunch of other examples, greater than, less than, greater than or equal to, less than or equal to. Those are all comparison operators. You're comparing left-hand side. Is this left-hand side for you guys? Yes. Left-hand side and right-hand side together, okay? And based on that comparison, the result is either true or false, okay? So based on that comparison, it gives you a true or false response. And we want to also point out that there is nothing like equal to, less than. That's not the right way of writing it. The order of writing it is very important. So as you can see here, greater than or equal to, you don't say equal to or greater than. Less than or equal to, you don't say equal to. Okay, so just make sure you identify those. So a few things we've talked about so far: Boolean expressions, true or false, the particular class or data type, the operator, which is a comparison operator, not an assignment operator, and some common errors that we can avoid. So we'll write those down in a little bit. Now, logical operators, those are another type of operators, okay? They have the same semantic meaning as in English language, like the and. You say, I am a boy and I am African, okay? So those two are true. If both conditions are met, then it's true. Anything else, it's false. If I say I am a girl and I'm African, obviously I'm not a girl, I'm a boy. So that is false. But if I use the or logical operator, at least one condition has to be met for it to be true. If one condition is met, then it's true. Otherwise, it's false. So for instance, I am either a boy or I am black. Both of them are true, so it is true. But if I said I am either a girl or I am white, both of them are false, so that will equate to false. All right. And a third option for logical operators is not. It just negates whatever value it was. So you go ahead and evaluate whatever expression is given to you before you negate it. And there's a nice table out here to point out a few things for you. As you can see, if A is false, that means if the first expression A is false, or it's called in this case sub-expression, and B is false, then A and B will give you false. A or B will also give you false. But if either A or B is true and the other one is false, then if you're using an AND logical operator, both of them will be false. But if you're using an OR logical operator, both of them will be true because at least one has to be true. But now if you want to negate A, which is in the first column, all you have to do is reverse this value to give you the value on there. All right. So it's always beneficial to use logical operators when we want to test sub-expressions, left and right expression or multiple expressions in that case, or we want to look at multiple conditions, which we're going to see. These are all things that we need to talk about because they are the ones that drive us into getting into conditional execution. All right. What questions do you guys have? Now, logical operators, those are another type of operators, okay? They have the same semantic meaning as in English language, like the and. You say, I am a boy and I am African, okay? So those two are true. If both conditions are met, then it's true. Anything else, it's false. If I say I am a girl and I'm African, obviously I'm not a girl, I'm a boy. So that is false. But if I use the or logical operator, at least one condition has to be met for it to be true. If one condition is met, then no question so far. It's as clear as mud.
I don't understand the negate, the not expression.
Okay. Very good. Very good. You do not understand the negation. Let me try and do an example for us. Examples are always good. I'm going to go into our Python. Sorry, our Anaconda in the cloud, and probably start a new notebook on here. Let's create a new notebook and call that day 3. Yep, I'm going to select that. All right. Let's rename this day 3. And if we take an example, let's try the example that we had. 5 is equal to 5. Oops, you cannot see. I don't know if you guys can see. Let me make that bigger. If we use this and execute that, it tells us it's true. But if we say not 5 is equal to 5, what would we get in this case?
False.
False, because it's going to give us the reverse of whatever we had in the first place. Now we get an error. Why do we get an error? Because not is not defined. The way I've written it, it means this is a function. So if I want to write it that way, let's put it that way. Now we're saying not 5 is that. That should also still give you an error message because we're trying to get a negated value. So let's say A is equal to 5 and B is equal to 6. C is also equal to 5. Now we can go ahead and execute that. Nothing is going to happen. But we can now compare these. A is equal to B. That should give us false. Let me go ahead and if we execute that, we should have false. But if we say A is the same as C, this should give us true. Spell correctly. So that gives us true. But if we wanted to negate, say A is not the same as B, oopsie, not B, then we're saying that this is not that. So it should give us true, right? Let's execute that if I can try it. No, it doesn't. No. Awesome. So let's try this out. Since it's not being nice to me on there, I'm going to go ahead and create a new folder. So here I'm using Visual Studio Code. A few things to point out before I get into that. Visual Studio Code, it has many options to the left. This is your Explorer. That's if you want to search. That's for source control, which we'll talk about, Git and so on. That's for running and debugging. These are extensions, and that's for testing. So we'll talk about those later. But for now, understand that I'm in a folder on my desktop, and I'd like to add another folder in there that says day 3. Within the folder of day 3, I can use this to add a new file. And let's say 01 conditions. And in here, I'm going to say a equal to, I'm going to assign a value of 5 for a. Oops, that's wrong. I should rename that actually to end with .py. That way it's a Python file. Now that it's ended with .py, I will be having, you can see the icon right there, and it's going to help me with a lot of IDE stuff like color coding and highlighting, also giving me autocomplete. So let me make that bigger so you can see clearly. All right, so B is 6 and C is 5. And now I like to print value of, oh my goodness, I should make that smaller. There you go. I like to print the value of A. Is it equivalent to B? Next, I like to print the value of A. Is it equivalent to not B? Right, so here it's going to give me an error message, and I can see that not is not a function. Yeah, it wouldn't want me to do that. I have to use a full expression to be able to do that. So since I can't use a full expression, that's why it's giving me that error. So if I want to do that in this case, I should use that. And I don't need those quotes for B. Okay, so that's how I'll go about printing that in Visual Studio Code. In order for me to run Python in Visual Studio Code, I need an extension. Extension, again, those are the things that make IDEs very powerful. In this case, Visual Studio. So if I click on the extension, you see that we have the Python extension that's already included in my script. Okay. Normally, when you open it, you should see something like this. It will tell you the extensions that are installed, the ones that are popular that you should probably install, the ones that it recommends, depending on what exactly you're doing. So in this case, I have 7 of them installed, a lot of them that are relating to Jupyter and the Python one, because when I installed, when I decided to create a Python file, it recommended that I do all those things. Because I've installed that, I have this icon at the top right, which can help me press play to run the Python file. If I press play, I was already running other stuff earlier, so it takes me back to what I was running earlier. And in this case, this is what it ran. It went ahead and used Python 3 to execute this file, which is in my desktop in my Python folder, in the 3 folder, which I just created. Let's go back to the Explorer in this folder, and that's the name of the file, conditions. And in that file, we're able to print out the result of line 5 and line 6. I can go ahead and clear this out. So let's try running it again. And in this time around, I'm going to say is, oops, let me put a quote, is A the same as B? So that is going to give me an answer. And I could probably do the same for the next one. Oops, I need to copy that. Let's copy this. Is A this? It's A not the same as B, and you get that. So it's going to give us a more descriptive result. In this case, if I execute it, it runs that, and it tells me is A the same as B? False. Is A not the same as B? True. So to answer your question, let me minimize this and go back. Yes, question. Go ahead, Aaron.
Yeah, I was just playing with the code here. It seems like if you assign that expression to another variable, the not works.
Exactly. If I went ahead and said the variable of is the same should be assigned to A equivalent to B, then now I'm saying this is going to be true or false.
Yeah. So I just did just kind of a simple thing. A equals to B. Sorry,
Yeah.
A equals to 4.
Yeah.
And the next assignment was B equal to 4.
Yeah.
And then I did C equal not A equal to B. So that I got false because actually A and B are the same, 4, 4. And then I changed B to 5. And then I did C equal not A equal B. And then I got true.
Okay, so if I were to say this and then I use not.
Yeah, I used the not immediately after the equal to sign.
Like that?
No, immediately after the assignment. The first one.
Okay, the very first one.
Yes. And it's a lowercase NOT I just used. And then space B without the brackets.
Yeah, I think this should work just fine, though.
Okay.
Now that I realized that I was using capital N instead of lowercase n.
Yeah.
Yeah, so in this case, again, I can still say A is equal to assigned to is the same as not B. Expected expression, no quick fixes. Yeah. So again, do I want to make sure that they are the same? Again, not is going to negate. So to answer your question, for and if we assigned and said this is true, and we assign that value true, in order for us to use the not in the case, we can say not this is true and assign it to another variable. Say this is false. Now we can go ahead and print those two variables. Let me go ahead and comment this out. Shift Control K, undo. Shift Control K, Control C. Oops, I cannot remember what was the shortcut for commenting out.
It's Control/.
I'm using an Apple computer. That's why it gives me a.
That would be I think Command/.
Okay, Command/. Oh, excellent. There you go. Excellent. So now that I've given this not operator is then used to negate the value in here. The value was true, so I can print those two in there. The first one would be this is true, and the second one would print this is false. Now if I print those, let's add comment in there and say true, and add another one for false. And if I execute this time around, it tells me true, gives me true, and false gives me false. All right. So going back again to what we were using earlier, I should not be using a capital letter in here. I should be using a lowercase, as you can see. So that lowercase is what the issue was. I have been preaching to you that case sensitivity is important, and I fell for my own trap. So does that make sense? And does that clarify your question earlier?
Yes.
Awesome. So as you can see, it's useful to also use multiple IDEs or multiple tools. Otherwise, I will not be able to tell that not should be lowercase, definitely lowercase. All right. Very, very good question. Please don't hesitate to stop me if you have any questions. So we can also use that not, say not A, execute that, it says false. But why would it say false if A is 5? Does anybody know why that is?
I don't think I got the question.
So in this case, I said not A, and it says false. But if I type in A and execute that, A is 5. So I'm saying that not 5 is equal to false. Why is not 5 equal to false?
I'm gonna guess because okay, now this might be stupid, but again,
That's
it's Easter, so I wouldn't worry. I'll say it. Because that is a string and it's not mutable. Therefore, with the not, you're not changing anything.
Okay, so good, very good try. And in this case, we're just saying 5 is an integer, right? because if you check the type of 5, it will tell you it is an integer. So the point I'm trying to make here is there are only 2 numbers that are always going to be false, 0 and none. Every other number is true. So if you say not true is equal to false. If I were to say not 0, what answer would I get? So let me go ahead and make a comment here. 0 is false. And also another comment on, oops, can't spell, on is false. So these are the 2 things that you want to always remember, oops, that are false, 0 and none. So if I say not 0, I should have true, okay? So for some reason, Boolean is always going to say any number that is 0 should evaluate to false. Any number that's none should evaluate to false. Every other number is true, okay? So if you're doing a computation and you're going to use them to decide a Boolean value, be very careful with integers. Integers will always evaluate to true, except it is a 0 or a none value. None is an unknown value, absence of a value. Sounds good to everyone? So it's going to make more sense once we get to the next part. So let me jump again back into where we were talking about logical operators, okay? The AND, when you have both sub expressions, at least one of them has to be false and then it's false. Both of them must be true for it to be true in case of an AND operator. But for an OR operator, at least one of them has to be true for it to be true. But if you're going to negate the value, it's just going to change it from whatever value it was in the first place. If A is false and B is true, then the opposite of false would be true. The opposite of true would be false. Sounds good? So it's going to make more sense once we get to the next part. So let me jump again back into where we were talking about logical operators. Okay. Awesome. So let's jump right into conditional execution then. Why do we need conditional execution? It helps us check conditions and it will help us change the behavior of our program. Okay. The conditional execution usually starts with an if statement. So the if statement begins and then it's followed by the condition. What condition is it that you want to check? At the end of that statement, you have a column. After you have that column, you then indent. Your next statement gets indented. It gets shifted inside because Python is very, very strict with white spaces. If you're going to shift it by giving a space 4 times, you have to consistently use that. If you're going to use a tab, you have to consistently use that. It makes your code looks readable, easy. If you use 3 tabs and then 2 tabs, it's going to give you an error. If you use 3 spaces and then 4 spaces, it will give you an error. So just be consistent, okay? So when you indent a statement, if that statement is true, that indented statement executes. But if that condition is false, that indented statement is skipped. For instance, you can give instructions. Remember, each statement is an instruction. You can give your kids instructions and say, if it is a weekday, wake up and go to school. If it is a weekend, wake up, don't go to school. So depending on that condition, it is a weekday or it is a weekend. If it is a weekday, that condition is true, the next block of code is executed, okay? And as I just pointed out to you guys, 0 and none are considered false. Every other number is true. So I'll talk about using the Python interpreter later. Again, the Python interpreter comes with Python. When you install Python, you can go on your command line and write that in there, okay? When you use the Python interpreter for a conditional statement, when you use that column after the header, okay, it gives you 3 dotted lines to show that you're not done typing your code. You have to get into the body now. But the if statement, you see a lot of statements that look like this. The if statement, the loops that we'll talk about tomorrow, and also the functions that we'll talk about next week. Those are all known as compound statements. We have been using simple statements so far, single line all the time. But now we want to use multi-line statements. Those are compound statements. They usually have a header line. That header line ends with that column. And then the next is indented. The next is known as a block of code. A block of code is just sets of code. So when you indent the next block of code, you have to have at least 1 line of code in there. You could have 10, 20, 100, it's up to you. All of those are seen as 1 block, okay? If you don't want to type anything in there, maybe you're still developing your application and you come back to insert it later, you can use the pass statement. Okay, when you use the pass statement, it's just going to skip and continue doing something else. But if you want to look at it visually, when you start going down your execution, this diamond means that's a decision that needs to be taken. In this decision, you check if the variable x is greater than 0. If the variable x is greater than 0, then you print x is positive. Otherwise, you go down this path and print something else on this side and so on. Does that make sense to everyone? Sounds good? Do we want to take a look at an example of what that is like? So I know we did an example. One of the things that I needed you to do in your assignment was to write a code to calculate certain things. We'll look at that later. But let me give you an example of using, let's escape out of here so I can go back to, again, I'm going to be fluctuating between Jupyter and Visual Studio Code. In case I want to show something very easy, I'll just use Jupyter. So if I want to go ahead and write a quick conditional statement, right, with an if, to write a conditional statement, let's go ahead and start with the if keyword, okay? As you can see, all the keywords are always bolded or in green. So if a is equal to 5, will that work? I don't think that will work because we are using one equality sign. That is going to give us an error. This is an assignment operator. We're saying that 5 should be assigned to a. So if we want to check if a is 5, we should use 2 equal signs. In this case, we are saying a is equal to 5. This would be a condition, okay? The condition that needs to be met, and then the heading should be ended with a column. And if you press enter, you can see the indentation is set up right there for you. So whatever else we type in this space is going to execute if a is equal to 5. Okay, so I can go ahead and maybe just put a print statement that says a is equal, I should use lowercase, equal to 5. Now let's execute that. You see the code gets executed. But if we had another value, let's say 50, and we execute it, nothing happens because this line of code is skipped. It's skipped because this condition is false. The condition is not true. Does that make sense to everyone? Excellent, excellent. So again, that's just the easiest way to look at conditions. You could change that and say if a is equal to b, let's do, oops, why is it not going? B, oops, 2 of them now. A is equal to b. You could also write another line of code. If a is equal to c, let's print a is equal to c. We do that and execute that. What do you think is going to happen in this case? Any ideas? Again, remember that we've already defined a and c initially. We defined a to be 5, b is 6, and c is 5. And now that was done on cell 4. But if we go down to cell number 18, we're going to test those values.
Yeah, that should evaluate to true. Therefore, the print statement should work.
Okay, so print statement, is it going to work for this line or for that line?
For the last line, because I saw A is, what was it? Yeah, I think A and C are the same from the assignment book. Yeah.
Okay, awesome. So let me execute that and let's see what we get. So yeah, A is equal to C. And you can see that the second line was skipped because A is not equal to B. But the first line was not skipped because A is equal to C. So you can set up conditions on how you want your code to execute. Later on, when we put all of this into perspective, it's going to make sense to us why we do things this way, okay? So that's just a quick example on how you do it. Now, there are some cases that you might have multiple conditions, right? It's not always going to be easy to just say, okay, if your name is DK, do this. If it's Monday, do that. If you have to check each one of those conditions, it becomes really cumbersome and difficult to deal with. So we'll talk about that next. So I know we did an example. One of the things that I needed you to do in your assignment was to write a code to calculate certain things. We'll look at that later. But let me give you an example of using, let's escape out of here so I can go back to, again, I'm going to be fluctuating between Jupyter and Visual Studio Code. In case I want to show something very easy, I'll just use Jupyter. So if I want to go ahead and write a quick conditional statement, right, with an if, to write a conditional statement, let's go ahead and start with the if keyword, okay? As you can see, all the keywords are always bolded or in green. So if A is equal to 5, will that work? I don't think that will work because we are using one if. So that was an easy way to look at conditional executions. So again, if this condition is met, go ahead and execute that. Otherwise, skip it altogether and just go straight to the next line of code. Okay. Now let's check out alternative executions. So alternative executions is usually when you have two possibilities. Okay. The condition determines which of those alternatives to execute. Okay. So it's usually known as the if then else logic. Okay. Each of those alternatives are known as branches, as you can see here. You're pretty much just checking if x can be divided by 2, meaning if you divide x by 2, remember we talked about the modulus operator. If the remainder is 0, then x is even. If the remainder is not 0, then x is odd. At the end of the day, you proceed with the next piece of code you have. So this is how you go about coding that. If x modulus 2 is equal to 0, print that it's even. Otherwise, print that it's odd. You just have two options. Choose this or that. Okay. So because we know that condition must either be true or false, we're always going to execute just one alternative and not both of them. Does that make sense? Any questions? So let's take a look at that. In this case, I'm going to switch over to Visual Studio Code. Let's see if we can write a quick one here. Let me add a new file, and I'll call that 02_if else.py. It takes me straight into the file. I'm going to give A, assign it a value of 1, and let's make it interesting, 11, and assign B a value of 20. And let's go ahead and write our code. If A can be divided by 2, let's use a column. It takes you to the next line of code. Then we go ahead and print A is even. Otherwise, let's go ahead and do our else. Print A is odd. End of case. So it's as easy as that. It is usually not so easy to write the code if it's Java or C# or any of those other programming languages. Now we can go ahead and let me clear this. Now our console is cleared. Let me drag that up and execute it. To execute it, all I have to do is press the play button. If I press the play button, it's executing that script, which I've written here, and it tells me 11 is even. That's because I made an error. This is divisible by that. I forgot to make sure that I have a left-hand side and a right-hand side. So I need to make sure that there's no remainder. Now that I check that there's no remainder, as you can see before, when it evaluates that, it evaluates to true. So it's going to tell you it's even. Why does it evaluate to true? Because when you divide that, you have a reminder that is not 0. Remember, anything that's not 0 is considered true. Anything that is 0 is considered false. Anything that is none is considered false. In this case, we are comparing this expression to 0. If this is true, we know that it's even. If it is false, we know that it's odd. So if we execute this, now we should have 11 is odd because we are comparing it accurately. Sounds good? Is everybody familiar with the modulus operator? We talked about it yesterday. Or not yesterday, last class. So again, the main thing here is this condition. We can change the condition and say if A is greater than B, That's another condition. What do you guys think? Is A greater than B?
No.
So we can say A is larger than B. That's going to print that. If it is not, we can say A is smaller than B. If we execute that, it should tell us what the value is. 11 is smaller than 20. Okay. So the condition tells you what exactly should print, what exactly should be skipped. We can go ahead and also maybe we talked about inputs last time. So we can go ahead and get a user input and ask them and say, enter a number. We tell them to enter a number. We can then evaluate that number. If the number is greater than that, we can say the number is larger than our number. So if I execute that, it's asking me to enter a number. Let me enter a number of 100. An error because that is a string. In order for me to compare it, I need to convert it to an integer. So these are some of the things I will talk about at the end of the class, how to handle this type error using the traceback. Okay. So now that I've updated it to change it to an integer by casting it with an integer, I should then, let me go ahead and use this and \n to take it to a new line. Execute that, enter a number, 200. Oops, wrong place. I should enter it here. Tells me 200 is smaller than 20. I wonder why.
Mm-hmm. So do we need the modulus operator in that case then?
No, we don't need the modulus operator, but we don't need this equality sign because it's telling you that this greater than this should be equal to 0. So that's a part that I missed. So we definitely don't need that. We just want to compare these two. So let me go ahead and clear this out again. I don't like when there's too much on the screen. So let's clear that out. This is our condition. Our condition is asking us to enter a value. Now let's enter a value of 25. 25 is larger than 20.
Yeah.
Okay. So now this is just when we have two options, but that's not always going to be the case. And sometimes you might have more than two options. What if I ask the person to enter a value and they enter 20? What do you think will happen?
Yeah, the operation will not be valid. Therefore,
so
it's going to be equal, right?
It's going to say it's smaller. Because it's just going to check the first one. It's going to check is 20 greater than 20? No, 20 is not. So it's just going to lie to you that it is smaller. So you want to make sure that you know how you handle those examples. But let me go back to where we were. Alternatively, we're looking at alternative executions. So that's something that we'll talk about when we come back from our break. But I want to make sure that you understand this clearly. And the next thing we have to do is get on a break. When we come back from our break, we'll talk about chained expressions, nested expressions as well. And in there, we're going to understand what are the other options that we can get. But before we get on break, what questions do you have?